tallest building in the world. It's 2,716 feet. It's called the Burj Khalifa, and it dominates the skyline of Dubai. It is the skyline of Dubai. It's like a needle.
There are skyscrapers, and then there's the Burj Khalifa, a building so tall that from the ground, its peak often disappears into the clouds. At 828 meters, it's still the tallest building on Earth. But surprisingly, height was never the biggest challenge. The real problem was the ground beneath it, because before a single floor could be built, engineers had to answer one terrifying question: what happens when you place the weight of an entire vertical city on top of a desert? Unlike cities such as New York or Hong Kong, Dubai isn't built on solid bedrock. Beneath the surface, there's mostly sand and weak rock, perfectly fine for ordinary buildings. But a skyscraper nearly 1 kilometer tall is anything but ordinary. If the foundation failed, the tower could slowly sink, tilt, or crack under its own weight. And once construction reached hundreds of meters into the sky, there would be no way back. Yet despite the risk, Dubai wanted to attempt something no country had ever done before. Not simply another record-breaking skyscraper, but a building so extraordinary that it would instantly become the symbol of an entire nation. At the beginning of the 2000s, Dubai was growing at an incredible pace. Luxury hotels, artificial islands, entire districts appeared almost overnight. The city wanted the world to see it, not as a place of oil, but as a place where impossible ideas became reality. There was just one problem. Nobody had ever built this high before. There were no instruction manuals, no proven construction methods, no guarantee the project would even succeed. Every extra floor meant more weight. Every extra meter created new engineering problems. And before engineers could solve any of them, they first had to make sure the tower wouldn't disappear into the desert, because if the foundation couldn't support the Burj Khalifa, nothing above it would ever matter. So instead of asking, how do we build the tallest building in the world? The first question became something much more important. How do you stop it from sinking before it's even finished? The answer lay deep beneath the surface. Engineers knew a traditional foundation wouldn't be enough. There was no solid bedrock close to the surface. So instead of supporting the tower from one massive slab, they spread its weight across the ground. The solution was nearly 200 reinforced concrete piles, each extending around 50 meters into the earth. Together, they acted like enormous anchors, helping transfer the building's weight into stronger layers below. Above them, workers poured a concrete raft almost 4 meters thick. It would become the invisible base of the world's tallest building. But even that wasn't simple. Dubai's extreme heat created another problem. Fresh concrete heats up as it hardens. On a scorching summer day, that temperature can become dangerously high, causing tiny cracks to form inside the structure. For an ordinary building, that might be acceptable. For the tallest tower on Earth, it wasn't. Engineers adjusted the concrete mixture, cooled the materials before pouring, and carried out much of the work during the night. When temperatures were lower, every batch was carefully monitored, because once the foundation was complete, there would be no second chance. Months later, the foundation disappeared beneath the ground. Almost nobody visiting the Burj Khalifa today will ever see it. Yet, it may be the most important part of the entire building. Only after that hidden work was finished could the tower finally begin to rise. Floor by floor, week after week, Dubai's skyline started to change. The higher the building climbed, the more incredible it looked. But engineers weren't celebrating yet, because they knew the real challenge had only just begun. At extreme heights, gravity is no longer the greatest threat. The wind is. And the higher the Burj Khalifa reached into the sky, the more that invisible force tried to push it back down. The higher the Burj Khalifa climbed, the more dangerous the project became. Not because of its weight, because of the wind. At nearly 1 kilometer above the ground, air doesn't simply blow past a building. It flows around it, creating powerful swirling forces that can make even massive structures sway. If those forces repeat in a steady rhythm, they can place enormous stress on the entire tower. For the Burj Khalifa, that risk had to be eliminated. So instead of making the building thicker, engineers changed its shape. From above, the tower resembles a three-pointed flower. As it rises, each of its three wings ends at a different height. The building constantly changes its profile. That means the wind never flows around the same shape for very long. Before strong vortex patterns can form, they're disrupted. Again and again. It's a remarkably simple idea. Instead of fighting the wind, the Burj Khalifa prevents it from ever gaining control. But designing the tower was only half the challenge. Actually building it was something else entirely. The higher construction progressed, the farther every piece of steel, every worker, and every bucket of concrete had to travel. Then came the biggest obstacle of all, pumping concrete. Concrete is incredibly heavy. Pushing it hundreds of meters into the air requires immense pressure. Too much. And the pipes could fail. Too little. And the concrete could harden before reaching the top. To solve this, engineers developed special high-strength concrete and record-breaking pumping systems. Eventually, they pumped concrete more than 600 meters vertically, setting a new world record at the time. Every successful pour pushed the tower higher, until it finally became the tallest building ever constructed. But reaching the top didn't mean the engineering challenges were over. Because once the Burj Khalifa opened, it had to do something even more impressive. It had to function every single day, like an entire city standing on end. Once the Burj Khalifa officially opened, the engineering didn't stop. It simply changed. Because this isn't just the world's tallest building. It's a city, built vertically. Every day, thousands of people live, work, and visit the tower. Moving that many people efficiently is a challenge of its own. Instead of relying on one giant elevator system, the Burj Khalifa uses multiple elevator zones. High-speed elevators serve different sections of the building, reducing travel time while saving valuable space. But transportation is only one part of keeping the tower alive. Outside, summer temperatures in Dubai regularly exceed 45 degrees Celsius. Without powerful cooling, the glass skyscraper would quickly become uninhabitable. Its air conditioning system works around the clock, keeping the interior comfortable despite the desert heat. Even the water produced during that cooling process is collected and reused to irrigate the surrounding landscape. The outside presents another challenge. Dust and sand constantly cover the building's glass facade. To keep it clean, special maintenance machines are built directly into the tower. Hidden behind panels near the top, they lower platforms down the sides of the building. Cleaning every window takes months. And by the time the last section is finished, the first is already dusty again. It's a cycle that never ends. The Burj Khalifa itself never truly stands still either. On windy days, the tower gently sways. Almost nobody inside can feel it. But that tiny movement allows the structure to safely absorb enormous forces, exactly as its engineers intended. And perhaps that's the most remarkable part of the entire project. The Burj Khalifa didn't become the world's tallest building because engineers ignored the laws of physics. It became the tallest because they understood them. From a foundation buried beneath the desert, to a shape designed to confuse the wind, to record-breaking concrete pumps and hidden engineering systems, every solution made the next one possible. Today, millions of people look at the Burj Khalifa and see an incredible skyline. Engineers see something different. Hundreds of impossible problems, solved one after another. Because in the end, the world's tallest building isn't just a record. It's proof that the impossible is often just the next engineering challenge waiting to be solved.